Welcome to the session. Thanks for your time. I know that you guys are fighting today, and we have a word in German for it. It's called Suppenkoma, which means that's your soup coma right after you ate something. You're probably going to fall asleep. I definitely promise that I'm going to make this talk as entertaining as possible for you today. Who am I? I'm My Fear. That's my nickname. The one thing you find me on is definitely Twitter. And if you want to stay up with my latest rumblings, conferences I attend or speak at, you're more than welcome to actually follow my Twitter handle. I work as a developer advocate for a company called Lightbend. Even if I can't really see you guys, can you try to give me a brief hint if you ever heard about Lightbend before? Oh, wonderful. That is a big relief. Thank you so much. What does a developer advocate do? Well, it's actually pretty easy. We're obviously flying around, and we're talking about stuff that's close to our hearts, about technology that matters in the fields. And what do developer advocates do when they are bored and need a little bit more to do? They actually start their own conference. And this is what I did in Germany. So when we all agree that this is a wonderful conference, and I definitely will come back whenever I get a chance to. But if you want to see something really different, you badly need to look at JavaLand in Germany. JavaLand is happening in a theme park. So there are roller coasters and rides in the evenings and talks and everything you want to learn during the daytime. Wonderful food, and yeah, this is definitely something I put a lot of my personal heartbleed into. And I love that conference. So enough of advertising for today. Reactive integrations. First of all, this is a really big sentence. Something that is more than buzzwordy than we can even imagine. Why is everybody talking about reactive and microservices these days? Have you attended a microservice talk today already? Hands up? Obviously, right? So this is like, who's doing microservices? Okay, so what's the rest doing? Just shout at me, we're trying to keep you awake today. Spring Boot? No, microservices. Spring, classical Java E stuff? Okay, couple, right. So, biggest problems in software development. Just a little recap about why we're here today. This comes out of a survey that we did with our customers, and I think it's pretty obvious that meeting demands is a problem. We have some issues with release frequency, which is also pretty obvious. Infrastructure cost, so maybe moving to the cloud, pay for what you actually get, is a thing. But the biggest thing is obviously developer velocity. People, methodology, code, systems. But there's another thing, like more users. So this is obviously referenced from the internet. There's a little URL in all my slides, in most of my slides. I consider that homework for you to actually look it up after, whenever you get a chance to get hands on the slides. The reason why I call it homework is because I have two beautiful daughters, 6 and 10, and believe me, I always hated homework, but now I hate it even more because they hate it. So I thought it's a good idea to actually give you something after the talk. We can briefly scratch the surface of so many things to look it up and work your way through it. So more users, more connected devices. Everything is going to be connected. Apple Watches have their own SIM cards. Cars start to actually be connected 24/7 to the internet. So we have a lot more users than 2002 when I started my career in that whole internet setting. What comes with more users is a bunch of more data. So whenever we look at business opportunities today, new use cases, we have a plethora of more sources to collect data from. And there's one example that I always like to bring. If you look at your cars, there was a car show in the States a couple of months ago, and one of the big CEOs disclosed how much data a reasonable 2018 car or 2017 car emits in terms of data every day, just by driving it. Anybody want to make a guess? Just shout at me. Gigabytes, terabytes? 10 gigabytes. More or less, anybody? Pretty close already. 25 gigabytes. 25 gigabytes, just by driving it. And yes, cars are bus systems, and that's exactly what's in there, right? I mean, this is what makes them tick. Imagine what somebody could do with this additional amount of data. Just think about insurances. So here's a nice little story. I do love fast cars, but I don't have that much money because I'm a poor developer advocate. So I bought myself a little Ford ST, Ford Fiesta ST, of course. Had to be cheap, right? But has 180 horsepower. And it's a lot of fun driving it in Germany, believe me. There's no real speeding limits, right? So you're more than welcome to try that out at some point. When I'm driving that car, we get places very fast, definitely. When my wife drives that car, it takes a little longer. And the car already has GPS built in, right? So what am I paying for that car, for car insurance a year? I don't know. Let's say it's $500. And she pays pretty much the same if she would have had the similar car. But she drives a lot safer. She drives a lot more conservative. Wouldn't it be fair if she pays less for insurance than I do, with a more risky driving profile? So just imagine our cars start to emit data about the GPS location, and the insurance company makes an offer together with your vendor to get map data from some company, Apple or Google, and mix that up and figure out how good and safe you really drive, what the average would be for a certain distance, what the speeding limits are in the certain areas. And depending on that, she would actually pay $50 a year, and I would pay $1,000. So that's one of those fancy new use cases. Another great idea, has any of you been on a cruise ship so far? Yeah, I guess like 1 or 2 people. Yeah, it's for old people, right? So nobody goes on cruises. That's super boring. And the cruise ship companies, they are struggling because what they really want to have on board are the cool people. So obviously just painting them in colorful colors doesn't really change it. And they were looking for ideas to make them more attractive. Like honestly, being stuck on a 2,500 people boat for 10 days is not really appealing to me. I want to see stuff. So one company started to equip all their customers with wristbands and the complete boat with sensors all over. So they were actively monitoring the behavior of 2,500 people on the boat. What's that good for? Ideas? Come on, I'm not going to let you sleep away. Yeah, behavioral tracking. What's the reason for that? We want to sell people stuff, right? Or we want to give them additional services. So just imagine me waking up in the morning, kids sound asleep, I need my coffee. So if I had like a little device or app on my phone that tells me where the next coffee shop on that chip is, because that chip knows I'll take a coffee every single morning. And there might be a fitness guy who really wants to run and wants to do something, and he doesn't really know how many gyms are on the boat. So he gets push notifications on his device, and he learns what he can do, depending on his behavior that he's just literally going around on that chip. Plenty more ideas what to do with those millions of amount of data. One thing that they all have in common is we can't just store them in databases anymore. So running batch jobs over the weekend is probably not a good idea. So what the requirements are, we need to move into that real-time processing space instead of doing those analytics and coming back with an answer for a question maybe a week later. And that means we're running into an issue with existing infrastructures. Centralized infrastructures classical RDBMS infrastructures are not really able to serve those needs anymore. And this is one of the main reasons for me personally why we're moving into those mini applications, into microservices, into decentralized infrastructures. And it's a good reason. We're able to scale way better depending on needs. We're able to serve our customers way more efficiently with microservices. And distributed space, honestly, to me as an engineer, this is a whole new world to play around with. It's amazing. So it has all the advantages. So learning about it is pretty cool. What is pretty uncool, though, is that all the mainframes and infrastructures that are already in place, that somebody paid millions of dollars for, and that are still doing a reasonable job for back office features or production systems, for example, they won't go away. Like, we're not going to completely rewrite all our infrastructures into microservices from day one. So what does that really mean? Ultimately, we have way more users and connected devices. We have a lot more data that we want to process. And we have a ton of more systems because we're now going distributed. And that means we end up having a lot more connections. And these aren't really microservice RESTful endpoint connections. These can be comparably heavyweight connections into backend systems. I was just talking to somebody, and we were talking about the top 3 or 4 or 5 connectors that Apache Camel customers usually use. Any ideas? What are the most important connectors? Database? Meh. Next one. Yes, absolutely. This is so important that mainframes can Twitter. JMS, FTP, and there are definitely a couple others that are talking to databases and aggregating data. But yeah, those classical like mainframe connectors are still the ones that are most important. What we are looking for is to scale this most common programming job that we are trying to solve, like all of us, every day. We take something from somewhere, transform it into something aggregated or do whatever with the data, and put it into another place. That seems pretty straightforward, and honestly it is. The thing here is it needs to work in that data-intensive world. And wasn't that the question you had? Isn't that just integration, like what we did many, many years before? The enterprise integration patterns is the Bible. Like usually, anybody working in enterprise settings has this thing sitting on the desk somewhere, or at least in a bookshelf. And all we need is maybe Apache Camel. Maybe it's already there. So yeah. Maybe SOA solved that for us. SOA was the new microservices a couple of years ago, a decade ago. But that didn't really work out, right? I mean, web services didn't really perform well. Schema evolution was a big problem from version to version. Testing in ESB scenarios, pretty much a nightmare, or just scaling those centralized infrastructures. That's anything that we really didn't want to have. So what's the big difference between classic integration frameworks like Camel and what we might need in our case here? What we really need is something that can work in this distributed asynchronous world. Instead of waiting for a process to finish calculations and getting back with an answer, we need to be able to scale that to a lot more individual calculations that get done per request in parallel, asynchronous, right? Does it make sense? This is the basic reason why we want to look into something new here and not work in a classical synchronous world. And if you're now asking what that really means for you personally, there is already that plethora of APIs and infrastructures out there. We have input streams and output streams. Java EE or Jakarta EE has various listeners. We have even the results set in JDBC. We can do a lot of things already that are capable of streaming data in an asynchronous way. Let me ask you a question. Can I pipe an input stream into an output stream in the JDK? Possible or not? Simple answer, it's not possible. I do have to read from an input stream with a loop and put it onto the output stream. I can't just cast an input stream into an output stream. And if you look a little bit more detailed into Java EE as a specification, you'll realize that every single layer has some features to deal with streams, but it's not cohesive and it doesn't not go through the complete stack at that point. And this is just the top of it. Even Java 9, which introduced something like the Flow API, which is basically the service provider interface for reactive streams, isn't fully implemented in the higher level APIs. And if we now go that one step further on top and talk about integrations, like skipping network boundaries, individual systems talking to each other with possible asynchronous boundaries in between, it might actually get worse, because we might end up having services with different capabilities. One service can produce messages at a certain rate, another service can't really follow up with that rate. What happens in that scenario if that service can't follow up and gets overloaded? Classical infrastructures, best point, Java out of memory. If you're not looking after your Docker containers and make sure you follow all the best practices, this is the end of the story at that point. So we need to have something more than just stream support in our individual components. We also need to make sure that we have flow control and something called back pressure. And back pressure literally means that one component knows about the load behavior of the other. And this is definitely something that the two components need to talk about. So one component can't just monitor the other because you would link them directly together. But the component who is the receiver of messages can definitely ask for more messages. So I'm not completely overloaded yet. Send me 10 more messages, please. And this is what's called back pressure. If we take that as an addition on top of the streaming framework that we're looking for, in a simple sentence, we're looking for a streaming-capable framework that can handle back pressure for integration. So yes, short story, answer first. Apache Camel as the integration library itself can't really handle back pressure across the board and can't work with streams, as in streams of data. So stream all the things is probably the answer to that. Akka is probably something you have heard of. It's an actor implementation on the JVM. But there's also a neat part of Akka, because Akka is a framework and has many different capabilities. One part of Akka is called Akka Streams, and Akka Streams can exactly do that. So why is that an option for you at all if you're not an Akka user? Because Akka Streams is an implementation, a real working implementation of the Reactive Streams SPI. So exactly that thing that is in the Java 9 JDK already. It's a cross-industry effort to standardize streams processing together with back pressure. Another little URL at the bottom. I should start doing QR codes on slides, maybe. This is a really long URL, apologize for that, but as I said, I hope you get the slides. This is a very lengthy post by one of our forethinkers and visionaries about what Java EE, Reactive Streams, how to get started with Reactive Streams. Jesus. What's the end goal of this exercise? The idea is to have some source somewhere have a flow step in between for transformations, and it doesn't necessarily have to be only one flow step, and have another place to put the result of your computation. And the real challenge here is to not only have that as a component system that connects inside one JVM, but also over asynchronous boundaries into other JVMs. What could use cases for all of this be? Good question, right? Obviously, because I put it into the microservices realm, the first use case that comes to mind is modernizing systems. We're thinking about our brilliantly new, shiny, reactive microservice that is running somewhere next to legacy, and that needs to talk to our existing legacy application. And I'm saying that in the most positive sense I could pronounce legacy, because I do believe that legacy applications are there for a reason. I built some of the biggest ones for automotive and insurances in Germany myself. And whatever I did back in the days, I'm still proud of. So I don't want to see that term legacy connected with something that is bad. But it's old, and it's not necessarily able to fulfill today's requirements. So when we invest some dollars into our new infrastructure components that are reactive, that are designed and built according to a microservices infrastructure, we still need to make sure that we're not connecting back to a bottleneck. So that's the big batch of use cases, first of all, that I'm interested in. The second batch is definitely the classical batch, like ETL runs, everything that pumps data from left to right and needs to do some kind of processing, especially in real time. So having those classical batch-style applications and moving them over into a more stream fast data approach is the second big category of use cases where you will have to work with flows and streams and back pressure. And this is how a streaming architecture could actually look like. Want to learn more about the second thing, moving batch to streaming and fast data applications? I can highly recommend this book by one of our VPs. Is he VP or Director of Engineering? Dean, don't blame me later on. It's a wonderful book giving you an overview and intro. And whatever book links and recommendations you see in here, they have all one thing in common. They are completely free. And they're digital, so you can just go to that website, register. I'll make sure you get your washing machine afterwards. But you can also directly download that PDF, right? Let's go back into that modernization approach. What is the right way of connecting back into legacy in the most stream-compatible way? RESTful web services? JMS, server-sent events? Might be interesting. WebSockets, at least WebSockets allow a bidirectional communication. So there's a chance of a back pressure implementation, right? What's the answer to that slide? The one and only possible is it depends. Obviously, it's an architectural decision based on your requirements at that point. You can use a lot of different ways, and you could even use JDBC at that point. Wait, did I say JDBC? Is JDBC capable of doing asynchronous processing at all? Not really. It's not. It's built on a synchronous and blocking thread, so it can't be asynchronous. But the important parts are streaming and back pressure at that point. So how do we bring that to Akka Streams? The only way to do that is to actually meet not a camel, but an alpaca. Alpakka is the code name for Reactive Enterprise Integrations in the context of Akka Streams. And it already has a bunch of connectors. They are growing with every release. The community is gaining a lot of traction lately. And it has a dedicated project lead now. We're pretty proud to welcome Enruna at that point. And he's driving all the efforts to get more connectors out there and help you do more reactive integrations. And I know that you are really looking for an example. So this is something I put together to access a local H2 database via JDBC. And the trick here is to not really use JDBC, but use a component called Slick. It's a library, it's a Scala database abstraction. And don't get me wrong, I'm a Java developer, so I'm not trying to sell you on Scala at that point. I promise you, you won't have to touch a single line of Scala just by using it, because the Alpakka connector encapsulates all of that for you. And Alpakka as Akka Streams, they both have a full-blown Java API. So the only situation where you will have to at least write the name Scala is in a Maven property. And even that shouldn't scare you, because the Scala version that both Akka Streams and Alpakka are built against requires some kind of marker for binary compatibility. So you need to have a specific Scala version encoded in the artifact name. And I promise that's the last Scala you read on my slides. Definitely. Let's look at two examples. So this is a really, really straightforward text area on a website served by Akka HTTP. And when you run that example locally for the first time, you can see 50 records coming into that text area field, getting streamed actually. And if you request that /more endpoint, 50 more records are streamed into, excuse me, into the database. And you can see that the text area is updated. Both examples are on GitHub, and you can play around with them if you want to look into the details. What else am I missing when I'm looking at camel and integration patterns? The actual integration patterns. So what we need to look into are the classical enterprise integration patterns. And I have to admit that Alpakka doesn't really have individual components, but that doesn't mean that you can't implement the individual integration patterns with Akka Streams. And this is just one example for a splitter that works pretty well. The community is taking contributions, and it's all open source. Nobody's holding you back. If you want to commit a couple of components and pre-build enterprise integration components, we would be very happy. Another thing that you could take with you is that Lightbend started to work with the microprofile efforts and Jakarta EE, and that we are committed on bringing the reactive approach, the working with fast data and streams, into those specifications. We really want to bridge the gap towards the classical infrastructures to make it easier to work with the new business requirements and streaming data. Another 2 URLs down there, couple of comments. It's interesting to watch that space over the next couple of weeks. I assume that the gremiums will be updated and a couple more information get out there. That's it for today, probably. May the source be with you at that point. Even more pointers here. The official Akka project website on lightband.com. That's probably just marketing, so you're absolutely safe to dive into the documentation for the latest release. Also, the GitHub repositories contain a bunch of examples. And again, both in Scala and in Java, you just have to look at the right place. Another link to my personal GitHub repository where the examples with, I believe, server-sent events and JDBC as connectors are located. And a couple of more recommendations for your travels back or for your weekend readings. Our CTO and founder of Akka, actually, he wrote a book about reactive microservices architectures, how to implement those systems in depth. It's an O'Reilly book. It's free. It's a PDF. So you can definitely download it. And the URL is, yeah, it's complete. It's a flown over microservice. And I was so sad when I joined Lightband and Jonas got to write his book. And I was like complaining, why is only a CTO always able to write books? So I obviously complained enough. So I got an opportunity to write my own book. And he was talking about architectures. So I had to talk a little bit about integration, a little bit about developing reactive microservices. This book uses one of our other frameworks that I didn't touch on today. It's called Logom. I highly recommend that you look into it. It's a microservice framework for the JVM. Pretty interesting. And if you're still at the point where you have to negotiate your way into microservices or try to prevent that microservices enter your project, this is an older book of mine, obviously written while I was still at Red Hat, but it's still up to date. It has a couple of recipes. It evaluates everything around microservice architectures. What does that really mean, going from those legacy applications into the modern space, into reactive systems? Yeah, and I think we have plenty of time for questions at that point. If you have any, I'm more than happy to answer. I'll be around for a little bit longer. Otherwise, you'll get a coffee after this. Questions? No questions? Sounds good. One question. When there are throttles. Problems. That's not back pressure, that's failure handling, right? I mean, failure handling is a different topic, and I do have a different talk on it. I believe it was recorded, but I need to dig that out. More than happy to talk afterwards. Failure handling is not part of back pressure. That's more about communicating, right? That was a quick run through today. Thank you so much.